Hey, hello everyone. Welcome to the video. We'll be looking at a problem of lowest common ancestor, which is based on binary trees. So we'll be given two nodes and we have to find the lowest common ancestor of those two nodes. So let's take a look at what does the lowest common ancestor mean. Here we are given the definition of a lowest common ancestor, which is as per the Wikipedia, and I looked at the Wikipedia also once, which also says the similar thing. So we have the definition here in graph theory. The lowest common ancestor of two nodes is the lowest node that has both V and W as its descendants. We are given with this visualization here, and if you look at it, so this is the tree, binary tree. We are given the task to find the lowest common ancestor of X and Y here. So the answer will be this node, because from this node I can reach X and also Y. It is the only unique node. Okay, let's look at the approach that we're going to take to solve this problem. So here we are given the example. Okay, we have to find the lowest common ancestor of P equals to 5, Q equals to 1. Those are here and here. For this problem, the lowest common ancestor will be 3, because it's the least node, which is at the max depth. Max depth means if I had another node here for 4, from 4 also I can reach 5 and 1, but that won't be the lowest one. 3 will be the lowest one. So 3 is the answer, from which I can reach both 3 and 1. And in this example, I'm asked to find the lowest common ancestor of 5 and 4. 5 is here, 4 is here. So in this case, the answer will be 5, because here the assumption is that the descendant, if it's like 5 and 4, if I'm asked to find the LCA of these two, LCA means lowest common ancestor, just in short form, the answer will be 5 itself, because I'm assuming that I can reach 5 from 5 itself, or 5 is the descendant of 5. So let's visualize this problem a bit. So we are finding what? LCA, which is lowest common ancestor. So there are three parts of this word. One is lowest. Lowest means if I have a tree like this of 1, 2 and 3, 4, if I'm asked to find the LCA of 3 and 4, it won't be 1, it will be 2, because 2 is the lowest one from which we can reach both 3 and 4. And common is, that's what, from it, see, the basic definition is, let me explain. If we take a path from 1 to 3, it will be 1, 2, 3. And if I take a path from 1 to 4, it will be 1, 2, 4. So which is the node that's common here? 2, right? That's what, 2 and 1 is also common, but 1 is on the top, it's not the least one. And ancestor means it is the ancestor. It's like in the real world, what does an ancestor mean? He is the one from which you are born, right? That's what in the tree also. In the tree, if I talk about ancestor, 1, 2, 2 is the child of 1. So 1 is the ancestor of 2, or 1 is the parent or ancestor. 2 is the child. So in binary tree we have 2 children, that is 1, 2, 3. We can have at most 2 children or no children at all, that's also fine, or one child. So I have to stop saying so. If I'm given a tree like this, so 1, 2, 3, 4, 5. So what is the basic approach? I see that lowest common ancestor is the one from which you can reach both the nodes P and Q. So in this example we'll have P and Q as these two nodes. I will see that there is just one unique node in the tree from which you can reach both of them. For example, 2 here can reach to 4 from its left subtree and can reach to 5 from its right subtree, and that is the only node which can do this. See, if I take a path from 1 to 3, it will be 1, 2, 3. If I'm asked to find the LCA of 3 and 4, it will be 1, 2, 3. So 1 is the lowest one from which we can reach both the nodes P and Q. So if I take 1, it can reach both P and Q from just the left subtree, and it cannot reach to any of the nodes from its right subtree. So this is ruled out. 3 is also ruled out because 3 cannot reach to any one of the nodes P and Q. So 2 is the only unique node that I have in this tree. So we have to find that only unique node which can reach both P and Q from its left and right subtrees. Let me define a simple pseudocode for this problem. So this is the, I'll have a main pointer which will be the LCA. It will be initially equal to null. Okay, then this is the solution which will have to return a node star. It will take a root and 2 pointers P and Q. Okay, sorry, P and Q. What I'll do here is I'll just have a helper function which will solve the problem recursively. Because coming to tree, every problem can be solved very easily by thinking in terms of recursion. Helper function which will take root P and Q, and I'll return LCA because I'm relying on this helper function to find the LCA. Okay, so let's define this helper function now. I have let my helper function return a boolean value, helper which will take the similar parameters which will be root P Q. Okay, now what if there's no root at all? If I don't have any root, then I have to return false. Then I have to find for nodes P and Q in my left and right subtrees. Let me define 2 variables, find left, which will find for any one of the nodes P or Q in the left subtree. Actually, this helper function it can be also named as find function because it searches for a node. So search find for a node. Okay, helper which will take root left P and Q, and it will return me whether it has found any node P or Q in the left subtree. Another one is bool find right, which will return me whether it has found anything on its right subtree, and it will be a bool value, just true or false. Now don't think about these functions, okay? These work like magic. Okay, just imagine that you have answer to these 2 recursive functions. So now using those 2 answers, what decision can I take? See, I told you before only, we just have one unique node from which I can reach to both nodes P and Q from this left subtree and right subtree. So that will be my answer, right? If both find left and find right, if both return true, then I know that my LCA will be equal to root node. For example, see 1, 2, 3, and I have to find the LCA of 2 and 3. I'm at 1, I pass this helper function to root left and it gave me true, and also from 3 I got true. So I know that 1 is that node from which I can reach both 2 and 3. So eventually 1 will be the LCA. Going further, there's also another possibility. Like I told you, a node can be a descendant of itself, right? 1 and 2. If I'm asked to find the LCA of 1 and 2, so 1 will be the answer in that case. To cover for that case, if my root is equal to P or root is equal to Q, here I'm checking whether my root equals any one of the nodes P and Q. That's not the only condition that I should have. Apart from that, I should get something from my left and right. That is find left and find right. Sorry, not and here. It has to be or find right, which means that I took that example, right? I have to find the LCM of this 1 and 2. I'm at this node, I passed to this function, it returned me true, and I went here, but it returned false. Now this P and this will be Q. Root is equal to P. That's apart from that, I should have true from any one of these, right? That's why I have and here and or here. I can have true from either left or either right. So that's how this case is. I hope it's clear. After that, if that's the case, then LCA equals that node, okay, root. Or else, what was my main function? What was my main purpose? What is the function doing? It is returning true if if it's found any value that is there in P or Q. For example, 1, 2, 3. I'm again taking the same tree. Pardon me. Forgive me. Here I'm at 1. Okay, I'm passing a fun recursive call to 2. So what should this do? It has to check if there is any node in this left subtree which equals to either P or Q. If it is, then it has to return true. So to do that, I can do return either root is equal to P or root equals to Q. Or if I found anything on the left, then I have to pass it on to my ancestor. Find left or find right. So that's it for this problem, and we'll also look at the code solution for this. Time complexity wise, it is traversing all the nodes of the tree just once, so it will be O of 1. Space complexity wise, you may think it's O of log n, but it's not. In case of a skewed tree, it's O of n, because it will be calling it again and again, and skewed means the height will be equal to the number of nodes in the tree, so it will be O of n in both the cases. Now let's look at the coding solution, which will be on Leetcode. So I have this class, which is a solution which will be called from Leetcode to verify the test cases, and I have this function lowest common ancestor, which should return the lowest common ancestor node, tree node. So what I'll do is I'll have a global variable. In classes I can have a variable like tree_nodes.lca, which will be equal to null, and I can access this variable in the helper function which I create. So helper function, I'll call my helper function which the root, passing P and Q to it, and after I have done, this helper function will calculate the LCA and store it in this LCA variable. After that, I have to return LCA. Let me define the helper function now, which will return a bool value. All the parameters are same, so let me copy this and paste it here. Now I have this. What if I don't have any root? They have given that there exists at least 2 nodes, but when I pass it, what if there's no root at all? If it's null, then I have to return false. If there's no node, then I cannot find these 2 nodes, right? And yeah, what this function does is it tells whether in that subtree it can find either of the nodes P and Q. If it can find any one of them, then it will return true. First it will check in a left subtree. Left find equals to helper left, pass it P and Q. Right find also similar thing. So I was talking about this thing. If my left is null, then it has to return me false. So this case is for this thing. Okay. Bool left find and right find. I have these 2 values now. If left find and right find, then my LCA will be true, as discussed in visualization. Or else I can have another case. In in where I can have root equals to p or root equals to q. If any one of that is equal, and also I should have either one of the left find or right find equal. Left find not equal, true. Left find or right find, then my LCA will be equals to root. Or else I've done these two things. Now what I have to return to my caller? I have to return whether I have found any one of the nodes p and q. So that will be root equals to p or root equals to q, or if I find anything from my subtrace, I have to pass it down to my caller. Find left, find right. So that's all. Let's run this code and see if it passes the sample test cases. Find left. Oh, it was left find and right find. Okay. RGHT. Let's submit it. And yeah, it passes. Thanks for sticking around. Let's see you in the next video.